I'm Jim Johnson. I'm a senior soils and crops consultant here at Noble Research Institute. Today we're going to be demonstrating our Rainfall Simulator. What this table is designed to do is to provide a simulated rainfall event. So each of these shower heads will put out the same amount of water, just like raindrops coming down and hitting the soil. And we'll be able to see the effects of that rainfall, whether it runs off the soil surface or soaks into the ground. The reason this is important to us, whether we're in agriculture or whether we live in the city, is because what happens to the rainfall out on our farms and fields influences to some degree whether we have drought and flood. If the rainfall runs off and doesn't get into the soil, we'll be more prone to have drought. Likewise, if the rainfall all runs off, then we could have exacerbated flooding. So what we want to do is capture as much of the rain that falls and get it into the soil and into the ground where we can store it to grow crops for the future. The soil in each one of these trays is the same soil type. These were all taken from within 1/4 of a mile of each other on the same soil type. Our first tray has no soil, it's just our check. Our second tray is bare soil that's had heavy tillage, lots of disking, lots of plowing, lots of rototilling, lots of tillage on this and no crop growing. Our third tray has wheat growing in it. It has been tilled occasionally over the past several years, and it has had some crop rotation. So it's had some wheat, it's had some beans, it's had various crops growing on it for the past several years. Our next tray is also wheat. It is no-till, so it has not been tilled in any way for years and years. It's planted with a no-till drill, so we just plant the seed directly into the soil without doing any tillage. It's had cover crops on it during the summer and the winter for the past several years. Lots of diversity in plants. And then our last tray is some native grass. It's got some little blue stem and some Indian grass in it. Native pasture, no grazing, but just managed as a native pasture. None of these have any livestock grazing on them. So let's turn it on and see what happens. So our first pan was our check. Obviously no runoff in the front. Everything filled the jar that would have been what soaked through this pan. It just simply went through the bottom of the holes in the pan and came out the bottom. And this gives us an idea of what that water would look like with nothing there. Nice and clean water, no silt, no soil, just all the water that went directly through and into our jar. For our clean-tilled, heavy-tilled soil with no crop on it, there's almost no water that soaked into the soil and came out the bottom. There's just a little tiny bit of dirty water in the bottom of the jar that caught what went through the soil and out the bottom. Almost all of the water on our clean-tilled, no-crop soil ran off the surface and into this jar. So when we have bare soil that's uncovered and has been disturbed with lots of tillage, we can have lots of runoff that takes the surface soil with it. Unfortunately, that topsoil is our richest soil. It's also where we typically apply our fertilizers to grow our crops. So when the water in the soil runs off, not only does it take soil with it, it's taking those fertilizers that we applied to grow our crops with it as well. Those eventually can end up downstream in our rivers and our lakes. In our field that has had some crop rotation and some tillage, we see we had some runoff. It's cleaner than our field that had heavy tillage and no crop, but we still have a little bit of silt in the water, some that ran off, but we had quite a bit that soaked in as well. It's a little bit silty, but not too bad. That's to be expected when it runs through the soil profile, through the soil, and into what would be our aquifer, or into the water table, into the soil water that we store. In our field that had had several years of cover crops and no tillage, we see that every bit of the rain that fell soaked into the soil and ran through the soil profile. There's very little water that ran off, and the water that did run off is very clean. That's because this soil is healthy, it's had healthy crops growing on it, it hasn't been disturbed with tillage, all of our soil and nutrients are staying placed in the field, and all of the rain that falls is also staying in that soil profile to grow a future crop. Our final field, our final pan is our perennial grass, perennial warm season grass. Every bit of the rain that fell on this field soaked into the soil. There's no runoff, zero surface runoff from our well-managed native perennial grass. Good cover on the soil, no nutrients leaving the soil, no soil leaving the field. All of our water is soaking into our soil profile and will be there to grow that grass for us during the dry season. I think an important takeaway from this simulation is the amount of runoff that we have from our disturbed soil sites versus the lack of runoff from our sites, whether they're cropland or grassland, that are managed using the soil health principles. Our two pans on the end have had the soil covered. We've minimized disturbance. We've had no physical disturbance in the grass, and we've planted with no-till in the wheat field. We've increased plant diversity. Obviously, a native pasture has a diversity of plants. While we're only growing wheat at this time, it's had a great diversity of cover crops grown on it. And we've kept living roots in the ground. Obviously, our native grass will have warm and cool season plants in it, so there's always actively growing roots. And in our cropland field, we've kept warm season and cool season crops on it to keep actively growing roots in the ground all year long. On the other hand, if we have soil disturbance, we have less plant diversity, obviously no roots in the soil in our bare ground, no cover on our bare ground. We can see what happens by not following those soil health principles, and we have water runoff and silt runoff. Hopefully today we've illustrated how our soil management practices can affect not only the soil and the water in the environment, but also the productivity of our crops and grasses on our farms and fields and pastures. If you'd like to learn more, we've put additional information in the description below, or you can check out this video or this video.